All right, you guys, here's on to the next lesson. On your yellow tab, you need to write graphing systems. And these notes will go on page 67. Okay, so there's that. Pause the video if you need to keep writing. Otherwise, here we go. Now, a lot of this is going to be very similar to what we talked about yesterday with identifying solutions. So we are going to be graphing systems of equations. So systems of equations might be intersecting on the coordinate plane. When those lines intersect, the point in which they cross each other will be called the solution to a system of linear equations. There are 3 different possible solutions to any system of linear equations. Okay, we talked about these yesterday. The first type of solution, there is only one solution. So a system with one solution intersects at one point. Okay, so whenever you have your 2 lines, this point of intersection right here, you write your answer as a coordinate point. So x comes first and then y. The other type of solution, there is no solution. So a system with no solutions involves parallel lines that will never intersect with each other. Okay, if you have parallel lines, your equations are going to have the same slope. So if there's the same slope, they're parallel, and these 2 lines will never intersect. Lastly, you can have infinitely many solutions. So a system with infinitely many solutions is exactly identical equations that intersect always. Okay, so basically if you have a line and you have another line right on top of that same one, it'll be the exact same equation and they will always intersect at every single point. So to see it in terms of equations, here's an example, y equals 2x minus 3. Then you would have y equals 2x minus 3 again. So the 2x is the same, and the minus 3 is exactly the same. So as long as they are the exact same equation, then you will have infinitely many solutions. Okay, so let's go back to the one solution example. Remember, if there's one solution, then it intersects at one point, and that point of intersection can be written as a coordinate point. So here's an example. We have y equals 2x plus 1, and y equals negative 3/2 x plus 8. So we need to graph it and then figure out the solution. So starting with the first one, I'm going to do this one in blue. This is in the same as y equals mx plus b, slope-intercept form. So b stands for beginning, begin with b. So my y-intercept is up here at 1. My slope is 2, so I'm going to go up 2, right 1, up 2, right 1. Okay, and then if I connect those points as best as I possibly can, there's an equation. That should be a straight line. Okay, my second equation, I'm going to do it pink. Start with b, so positive 8. 1, 2, 3, 4, 5, 6, 7, 8. and my slope is -3/2. So I'm going to go down 3, 1, 2, 3, and to the right 2, right here. Down 3, 1, 2, 3, and to the right 2. I'm going to do one more point. 1, 2, 3, right 2. And we're doing it pink. Okay, so there's my first line, there's my second line. We're looking for that point of intersection, which is right there. Okay, so this point right here is at, sorry, there's my solution. I'm going to go to the right 2, and I go up 1, 2, 3, 4, 5. So my solution for this equation is at 2, 5. Staying on the same mindset, looking at a table, so I'm still looking for one solution. I need to look at my y columns, and if my y column, remember, if they match and they're exactly the same, then it will be the solution. So 5, 2, those don't match. 4, 4, oh yeah, those match. So if they match, that would be the same thing as the point of intersection. So I'm going to highlight it. And my solution is at -2, 4. Okay, moving on. Back to the middle column with the no solutions. Remember, they are parallel lines, so they will never intersect. They have the same slope. So looking at this problem, we have y equals 5/4 x plus 3, and then we have 4y equals 5x minus 12. Now, this is not in slope-intercept form. I need to get y by itself in order to have it in slope-intercept form, and then I am able to graph it. So to get this by itself, I'm going to divide by 4. And what I do to one side, I have to do to the other side, all the way across. So when I do that, I end up with y equals, because the 4's cancel, 5/4 does not simplify, so I end up with 5/4 x, and -12 divided by 4 gives me -3. So now I can graph this one. This one will be in pink. This is my beginning value. So 1, 2, 3. I'm going to go up 5, right 4. 2, 3, 4, 5. Right 1, 2, 3, 4. I can connect those dots. Okay, there's my first one. And then I'm going to make this blue. My second equation blue. So I'm going to go down 1, 2, sorry. -3 is my beginning point. Start at the origin. 1, 2, 3. And my slope is 5/4. So I'm going to go up 1, 2, 3, 4, 5. And to the right, 1, 2, 3, 4. Okay. And if drawn correctly, then these are parallel lines. You can also tell because look, 5/4, 5/4, same slope. So the same slope means that there will be no solution. Sorry, no solution. Okay, and then looking at the table, look to see if any of them match. 527, 425, 323, 221, 119. None of them ever match, so again, it's no solution. Okay, so that's what happens when they're parallel. Lastly, Infinitely many solutions, again, remember that they are the exact same equation, so it is the exact same line, and therefore that they will always intersect at every single point. So working on the problem, y equals negative 4x minus 3. We can go ahead and graph that. Make this one blue. So my beginning point is at negative 3. 1, 2, 3. And my point, not my point of intersection, my slope is negative 4. So that means I'm going to go down 1, 2, 3, 4, and to the right 1. And then connect the dots as best as you can. Remember, your ID is a great straight edge. Okay, my second equation, I have y plus 3 equals negative 4x. Now, the only way to graph this, again, is to get it in slope-intercept form, y equals mx plus b. So I need to get this y by itself. So I'm going to subtract 3 from both sides. When I do that, 3 minus 3 is 0, so I'm left with y equals negative 4x minus 3. These two terms are different. I cannot put those together. So I'm going to end up with negative 4x minus 3. I'll graph this one in pink. Okay, again, my beginning point is down here at negative 3. And my slope is negative 4, so I'm going to go down 4 to the right 1. Here's my next point. And then I will connect the dots. Okay, but again, it's the exact same line. So it's going to be infinitely many solutions, or infinite solutions. Okay. Last question. Looking at the table. Okay, if you're looking at the table, check to see where they have it in common. Okay, well, it's common here, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Okay, so all of the points match. So there are infinite solutions. Okay, and that's it. That is graphing systems of equations.